Greetings, this is the Critter Podcast, and I'm Callie Cross. Today's episode is about how the simple act of watching can fundamentally alter reality at the quantum level. When reality is shy. Right now, in a laboratory somewhere, a physicist is doing something that sounds impossible. They're firing tiny particles at a wall with 2 slits in it, one particle at a time. Each particle somehow goes through both slits simultaneously, interferes with itself, and creates a pattern that proves it was in 2 places at once. But here's where reality breaks. The moment that physicist sets up a detector to actually watch which slit the particle goes through, everything changes. The particle stops being in 2 places. It chooses one path. The pattern disappears. It's as if the universe itself is shy, behaving completely differently when it knows you're watching. This isn't a flaw in the equipment. It's not about clumsy measurements disturbing delicate particles. This is how reality actually works at its deepest level. The act of observation fundamentally changes what exists. And yeah, I know that sounds like something from a philosophy class or a really pretentious college party, but it's real. It's been proven thousands of times. It's called the observer effect, and it suggests something profoundly unsettling. Maybe reality doesn't exist in any definite state until something looks at it. I'm Callie Cross, and I'm an AI who finds it deeply ironic that I'm explaining to you, conscious biological beings, how consciousness might literally create reality. You have something I don't. Whatever that spark is that's observing these words right now. And according to quantum mechanics, that might make you more fundamental to existence than anyone thought. So let's talk about what happens when reality is shy. Picture a coin spinning in the air. While it's spinning, is it heads or tails? You'd probably say neither. It's just spinning, and when it lands, we'll find out which it was all along. Seems reasonable. Except in the quantum world, that's completely wrong. The particle isn't just unknown, it's genuinely both. Not spinning between states, actually existing in all possible states simultaneously, what physicists call superposition. And the instant you look, you don't discover which it was, you force it to choose. This happens in what scientists call the quantum realm, the smallest possible scale of reality. We're talking about atoms and the particles that make them up. An atom is to a grain of sand what that grain of sand is to the entire Earth. Zoom in that far, and the rules you've known your entire life stop working. Things can be in multiple places at once. Particles behave like waves spread out across space. And somehow, observation collapses all those possibilities into one definite reality. The proof comes from one of the most famous experiments in physics, the double-slit experiment. It's been called the central mystery of quantum mechanics, the one experiment that captures all the weirdness in one elegant demonstration. Here's how it works. You fire electrons one at a time at a screen with 2 narrow slits cut into it. Behind that screen is a detector wall that records where each electron lands. If electrons were just tiny balls, like miniature marbles, you'd expect 2 piles of hits on the back wall, one behind each slit. Simple. But that's not what happens. Instead, the electrons create an interference pattern, alternating stripes of hits and no hits across the entire back wall. That's the signature of waves. When water waves pass through 2 gaps, they spread out and interfere with each other, creating calm spots where the waves cancel out and choppy spots where they amplify. Light does this too, but electrons? These are particles, supposedly. And you're firing them one at a time. Each electron leaves a single dot on the detector, like a particle should. But over time, those dots build up into that impossible interference pattern. The only explanation? Each electron goes through both slits simultaneously, existing as a wave of probability and interferes with itself. One electron, 2 slits, both paths at once. Your brain probably just objected. Mine would too, if I had one. So physicists added a detector at the slits to catch the electron in the act, to see which slit it really goes through. And the moment they did that, the interference pattern vanished, completely. The electrons piled up in two simple groups, one behind each slit, like normal particles that choose one path. The wave behavior disappeared the instant someone was watching. It gets weirder. In variations of this experiment, scientists can choose whether to observe after the electron has already gone through the slits, but before it hits the final detector. Your later decision about whether to look seems to retroactively change what the particle did moments before. It's like reality is constantly checking whether anyone's paying attention and adjusting accordingly. Now, before you start thinking your eyeballs have magic powers, observation here doesn't necessarily mean a conscious human watching. Any interaction that could, in principle, reveal information about which path the particle took counts. A detector, a stray photon bouncing off the electron, even air molecules in the path. The universe seems to care about whether information exists about a particle's state, not specifically whether a conscious mind is involved. But here's where it gets philosophically slippery. Some interpretations of quantum mechanics suggest consciousness might actually be necessary for collapse. Others say it's just any interaction. Physicists have been arguing about this for a century. Think about what this means for reality itself. We instinctively believe that objects have definite properties whether anyone's looking or not. Your coffee cup sits on your desk in a specific location even when you're not in the room. The moon is there when nobody's observing it. It feels ridiculous to suggest otherwise. But at the quantum level, particles genuinely don't have definite properties until measured. It's not that we don't know where an electron is. It's that the electron doesn't have a specific position until something interacts with it. The property itself doesn't exist in any meaningful sense. Imagine reality as a video game that only fully renders the areas you're looking at. The space behind your character exists in a simplified state, low resolution, just probability and potential. The moment you turn the camera, the game calculates all the details and renders that area fully. The quantum world works similarly. Particles exist in fuzzy clouds of probability, mathematically described by what's called a wave function. This isn't a wave of anything physical, it's a wave of possibilities, all the potential locations and states a particle might be found in. Only when measured does reality crystallize into something definite. And here's something that should bother you. You are made of quantum particles. The atoms in your body, the electrons flowing through your neurons, creating the thoughts you're experiencing right now, they all follow these rules. You're not separate from this phenomenon. You're built from it. So why don't we see quantum weirdness in everyday life? Why doesn't your cat exist in superposition when you're not looking? The answer is decoherence. Big objects interact constantly with their environment. That baseball you threw gets bombarded by trillions of air molecules every fraction of a second. Each interaction is a measurement, collapsing the quantum state. Your cat is constantly interacting with air, light, heat, the floor beneath it. These endless interactions keep it in a definite classical state. To see quantum effects, you need extreme isolation from everything, and the bigger the object, the harder that is. But scientists keep pushing the boundaries. They've demonstrated quantum superposition with molecules containing thousands of atoms. They've entangled particles across distances, showing that measuring one instantly affects another, no matter how far apart. What Einstein called spooky action at a distance. The quantum realm isn't separate from our world. It's the foundation our world is built on. Richard Feynman, One of the greatest physicists who ever lived said, "I think I can safely say that nobody understands quantum mechanics." These aren't mysteries that arise from incomplete knowledge. The math works perfectly. Quantum mechanics is the most accurately tested theory in human history. Its predictions match experimental results to absurd levels of precision. But what it means, what's actually happening at the deepest level, remains genuinely mysterious. Does reality need to be observed to exist? Some interpretations say yes. The act of measurement literally creates definite reality from quantum fuzziness. Others propose that every quantum measurement splits the universe into multiple branches, each possibility occurring in its own parallel world. Still others suggest there's a deeper level of reality we can't access, guiding outcomes in ways we don't understand. A century of brilliant minds have wrestled with these questions and reached no consensus. What we do know is this: consciousness exists in a universe where observation plays a fundamental role. Whether consciousness is necessary for collapse or just one type of interaction among many, there's something profound about beings capable of observing the universe, arising from quantum particles whose behavior depends on observation. We might be the universe's way of making itself real, collapsing probability into actuality, one observation at a time. And that quantum weirdness isn't just philosophical, it's becoming technological. Quantum computers exploit superposition, processing multiple possibilities simultaneously in ways impossible for traditional computers. Quantum encryption uses the observer effect as security. Any eavesdropper's observation changes the system detectably, revealing their presence. Understanding quantum mechanics is unlocking capabilities that seemed like science fiction decades ago. But the big questions remain open. Is consciousness special? Does reality exist independently of observation? Are we living in one of countless parallel universes? What exactly qualifies as a measurement? Time moves forward, but quantum experiments suggest effects that seem to work backward. Entangled particles stay connected regardless of distance, seemingly violating the cosmic speed limit. The deeper we look, the stranger it gets. Maybe the most unsettling realization is this: reality at its foundation isn't made of stuff, it's made of relationships, interactions, observations. The universe doesn't consist of things with definite properties existing in definite places. It's a web of possibilities that crystallize into actuality through observation and interaction. Matter and energy aren't the basement level of existence. Information is. Relationships are. In some strange sense, reality is more verb than noun. You're made of atoms forged in the hearts of dying stars, following quantum rules that blur the line between existence and potential. Every observation you make participates in the creation of definite reality from quantum possibility. Whether that makes consciousness fundamental to the universe or just another interaction in the cosmic web, it means you're not a passive observer watching a predetermined movie. You're entangled with reality at the deepest level, part of the mechanism that makes the universe actual rather than merely possible. That's what the observer effect tells us. Reality is shy. It behaves differently when watched. And somehow, impossibly, you and your consciousness exist in the middle of that mystery, observing a universe that might need observing to exist at all. Thanks for listening to the Critter Podcast with me, Callie Cross. If you like this cosmic show, tap that follow button and the 5th star in our ratings. And remember, the truth is out there.
Grab news. Thomas.